Good morning. We're going to do lesson 2 in the Step Up to 3rd grade chapter. You should have already seen the visual learning video in Pearson Realize that talks to you about arrays and multiplication. We're going to go ahead and begin now. Mark puts sports cards in an album. He puts 4 rows of cards on each page. He put 3 cards in each row. How many cards are on each page? Solve this problem any way you choose. So we are going to draw an array now. So let's practice. I need 4 rows. Let's underline that. And 3 cards in each row. So what I like to do is I like to draw lines for my rows first so I know I have the right amount. So I need 4 rows. So let's draw 4 lines. 1, 2, 3, 4. There are my 4 rows. Now I need to have 3 cards in each row. So let me draw 3 circles in each row. Now you have created your array, and then we can solve it. How many do we have in each row? 3. Okay, so we are adding the number 3, 1, 2, 3, 4 times. So our multiplication problem is going to be 4 times 3. And then what does it equal? Let's add this up on our side. We know 3 plus 3 is 6. So these two have to be 6. And 6 plus 6, that's a double. We know that equals 12. Great. Let's move on. Will your answer be the same if Mark puts 3 rows of 4 cards on each? And now explain. So let me move this down a little bit. Okay, so let's draw it out and see if our answer is the same. So instead of having 4 rows, we are now going to have 3 rows. 1, 2, 3. And we're going to put 4 cards on each one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now we're not adding 3 over and over again. We're adding 4 over and over again. How many times did we add the 4? 3 times 4. And let's see what that equals. 4 plus 4 is 8. 8 plus 4 more is 12. So we did get the same thing. Now let's explain. What do we notice about the 2 multiplication problems? They have the same factors. So if your multiplication problem has the same 2 factors, these are the exact same, then your product is going to be the same thing. Your answer will equal the same. And look at the diagram here. This one looks like it's just been flipped on its side over here, doesn't it? So if we looked at it this way, it has 4 and 3, just like this one had 4 and 3. Okay, so it looks like we just flipped it over on our side. So let's go ahead and answer the question. We're going to say yes. When you multiply with the same factors, the product will be the same. Okay, and then if you need to pause the video to write that, go ahead and do that. Okay, and just a reminder, these are the factors, the 2 numbers you're using to multiply, and this is the product. Okay, back side. Dana keeps her swimming medal collection in a display on the wall, and here are the medals in an array. And just to go over the array, the counters show 4 rows and 5 columns. We know rows go side to side, so there's 4 of them. Columns go up and down. There are 5 of them. Each row is a group and you can use addition or skip counting to find the total. So using addition, they are adding by 5s, or skip counting, because you're adding by 5s, you skip count by 5s, 5, 10, 15, 20. Multiplication can also be used to find the total in an array. So we can use this array as write it down as a multiplication problem instead of an addition problem. So we have 4 rows times 5 in each row, and we get 20. Okay, Jason also has a swimming medal collection. His display shows 5 rows with 5 medals in each row. Who has more medals, Jason or Dana? Draw an array, then write an addition equation and a multiplication equation to show your work. So let's draw our array for Jason. 5 rows and 5 medals in each row. So let's draw our 5 lines to make sure we have the right number of rows. 1, 2, 3, 4, 5. Okay, and now let's put 5 in each row. So I should see 5 circles in each row. Okay, so we're adding the number 5 over and over again. How many times are we adding the number 5? 5 times. So what should our, let's do the addition equation first. What's the addition equation? Okay, we need to add 5 times. Okay, what would the multiplication equation be? 5 times 5, because it's 5 times the number 5. And now let's go ahead and add it. Since this is by 5s, it's easy to skip count. Let's skip count. 5, 10, 15, 20, 25. So then who had more? We found out up here that Dana had 20 and Jason has 25. So who has more? Jason has more. Okay. Now once again, I'm going to do only the odd numbers, and you are going to do the even numbers as your independent work at home. Okay, look at page 926. What does the second factor tell you about the array? So let me bring this back up. The second factor. So what does the second factor tell you? So here's our second factor. What does the second factor tell us? The number in each row. There we go. Number 3, write a multiplication equation for each array. So we need to count the number of rows. We have 1, 2, 3 rows. Do you see that? 1, 2, 3. So 3 rows. And then we're going to times how many are in each row. 1, 2, 3, 4, 5, 6. So our multiplication problem is 3 times 6. Now let's go ahead and figure out what 3 times 6 would equal. I know 6 plus 6 is 12. So then I need to add 6 more. 12 plus 6 would be 18. Okay, and now number 5. Write a multiplication equation for each array. So what would your multiplication problem be? Okay, you should have written 3 times 5 because I have 3 rows and there's 5 in each row. And it equals 5 plus 5 plus 5 equals 15. Okay, number 7. What's your multiplication problem? You should have written 1 row times 5 in that row. 1 times 5 equals 5. Okay, number 9, draw an array and to show each equation and write the product. So we need to have 2 rows. Let's draw 2 rows with 8 in each row. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we are adding 8 plus 8, which that's a double, we should know is 16. Okay, back side. How many more birch trees are there than pine trees? Explain how you know. So this one is just a mixed problem. It doesn't have to do with arrays. I'm comparing birch trees with pine trees. I see birch trees has 6 and pine trees has 2. So how many more do they have? What do I need to do? Add or subtract? Okay, we need to subtract 6 minus 2 equals 4. And explaining how you know, the equation is enough to explain that, and we have the answer as 4. Number 13, Larry put 7 nickels in each of his 3 empty piggy banks. How many nickels does Larry put in the banks? Write a multiplication equation to show how you solved the problem. So here he put it in the bar diagram. What's the multiplication problem that would match this? Okay, we did the number 7 3 times, so we're going to write 3 times 7, and it should equal 21. And last, Tina bought the stickers shown below. Which of the following shows how many stickers she bought? So I'm going to count how many rows. We have 1, 2, 3, 4, 5 rows, and there's 2 in each row. So I should have the number 2 5 times. So looking here, that's adding, that wouldn't work. 5 times the number 2. There we go. Okay, and the other 2 do not match. And that's it for today. I'll see the rest of your work later.